Hello, welcome back.
Welcome back.
We are in the final leg now of our Umbraco Community Day. I hope you've enjoyed the day so far. I certainly have. Have you?
Yes, absolutely.
Yeah. It's going to get even better though.
Yeah.
We now have two fantastic guests all the way from Microsoft. We have Mads Torgersen and we have Dustin Campbell. Hello, both of you.
Hello.
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 Just needed to find my unmute button there.
Yep, me too. Hello.
And we've got Dustin. Hey both. How are you?
It's a little early in the morning, but
Yeah.
hopefully I can find my voice.
So, Mads, you're in Redmond, right?
Well, almost in Seattle. Yes.
Seattle. Okay. And Dustin?
I am actually in Redmond.
Oh, right.
So
Cool.
just
Fine.
a stone throw away from Mads.
Awesome. So, yeah, it's a bit early. Is it what 8 a.m. for you?
Yeah,
8:30?
it's 9:30. I'm just being silly.
Just haven't had a coffee yet.
He's
Okay.
just up that late all the time.
Fantastic. Well, Mads, we're quite familiar with you in the Umbraco community now. You spoke at Code Garden last year, but Dustin, you're a new face for us. Maybe I'll allow you both to just introduce yourselves quickly, and then we can have a little chat before your talk.
Well, new boy, go first.
New boy, okay. I'm an architect on .NET Tools. I've worked on the C# language design team for years and years. So I work very closely with the gentleman to, I guess, my right or my left, depending on which way you're looking at us right now.
Exactly. Either your right or your left.
Yeah.
Yeah, and I'm Mads Torgersen. I've worked on the design of C# since I joined Microsoft 17 years ago, and have been involved in everything since C# 3. So yeah, I've been around for a while and worked with Dustin in various ways since he joined 2 years later or something like that. So we go back, and we still like each other. So there's something there.
That's impressive. All righty. You say C# 3, Mads. That's clearly a very long time ago, because I mean we're on C# 11 now, but the versions of C# have been linear for a few years, but that's not been the case forever, has it? We weren't getting a version a year for we haven't always been getting a version a year.
Right. We sort of, when .NET went to yearly releases, we decided that was the best cadence for C# as well. So yeah, it's been more than 11 years.
Fantastic. Yeah, I mean, the Umbraco community, we got a little bit stuck behind. I think it's fair to say we were stuck on the .NET framework for quite a while. Umbraco 7, which came out, I think maybe 7 or 8 years ago now. 9 years ago? 9 years ago, I'm being told. 9 years ago was .NET 4.5, and so we were stuck with C# 5 language features, which is kind of annoying. And then with Umbraco 8, that started targeting 4.7. So we had the luxury of having some of the C# 6 and 7 features, but now we're in modern .NET world. We've got .NET 7, so we're all the way up to date. We've got C# 11, and it means the community is really now starting to explore and enjoy some of these new features that I guess you're going to tell us a bit about today. So
yeah, I think that's a plan. Yeah.
Cool. I heard before we went live that if anyone has a question throughout, we're more than welcome to just interrupt you and get you to answer the question there, which sounds lovely and a lovely way for us to finish off our day. If that's all right with you.
Yeah, that sounds great. Like we're going to go through some different things, and it's awkward if we get to the end and there are questions about the first thing we talked about. So it's easier if we just interleave the questions. I understand that we have like roughly an hour for this, so we'll try to do some timekeeping on our side to get to all the major points we want to try to bring. But within that, please jump in with questions from the audience. It's much more fun for us as well this way.
Fantastic. We'll give you an hour then, and I'll try not to geek out too much because we'll be here all night otherwise. So yeah, over to both of you.
All right. We're going to have Dustin share his screen.
Indeed. There we go. Is that visible out there?
Yes.
I see it.
Oh, good.
Yeah, we can see.
So,
Excellent. Okay.
C# 11 came out a couple months ago.
Yeah.
Bunch of new features as always. Here's what do you have on your screen here, Dustin?
So we have on our screen, we have something that we've been kind of noodling with every time we demo, whatever situation we're in where we need to demo something around the idea of classes that have data in them. And so this is our typical person class. And in here we're using a couple of new features. By new, I mean newish. If you're used to the multi-year C# versioning, where we release every few years, this is, some of these features might feel new because they were only released more recently. But we've got a person class with a first name, a last name, and then a middle name, which is defined as a nullable string because that's not required to be on this. And also these are initer only properties where they have an init setter. That means that they can be used in an initialized as a collection with an object initializer, as well as with a constructor. So they can be initialized in a way that allows them only to be initialized at construction time. Right.
Yeah. So I mean, it looks kind of lovely, but we've struggled with for a couple of years that there are these nasty little green squiggles there in the middle of it.
Nullable is such a blessing. It's the deliverer of warnings, and this one is particularly annoying to anyone that tries to do this sort of thing right now, right?
Yeah,
where you haven't assigned it in the constructor, right?
It's very helpful that the warning tells us that hey, you have something that's not supposed to be null, and it starts out as null, and we can't see you doing anything about that. So how about you fix that up? But up until now, this hasn't had there haven't been a lot of good options for how do you fix it up. Yeah, you can assign null to it and say it's all right, I got it, but then you get a warning on that instead.
Yeah,
and then
so
we have
fix that too.
Yeah, we have the INumber operator, the dammit operator also called. And that takes the warning away, but it doesn't take the problem away. Because the warning is right. You aren't really, I mean, we aren't ensuring initialization here. Same, of course, for last name. So,
so this is inconvenient, and it's causing you to go through. If you want to kind of shut these warnings up, you have to do something unnatural, right?
Yeah. And so we decided let's do something natural instead. The key of the issue here really is that people using an object initializer aren't required to provide these members. All members are optional in object initializers, and we want to change it so that you can make a member required. And how do you make a member required?
Yeah, exactly. Because right here, I just want to point out that, like, we're not assigning last name, even though it really should be, right? So, so we make them required.
So that's interesting. Right. So now this squiggle goes away because we have required the caller of the constructor to do their own initialization of these members, of these properties. And indeed, when you put the last requirement in there,
yeah, we don't have this member is required, so it must be set at this time, and that's why we get that error, which is exactly what you wanted. Right, and so now everything's fine, and we can guarantee that this object will have the right state after construction, and that could be either with a constructor or with an object initializer.
Right. So in essence, this kind of little wart with the nullable feature was actually like telling us something as language designers as well. Like it was kind of telling us there's something you're not dealing with here, and we dealt with it. So required properties.
Yeah. Now I want to actually point out something else that I noticed on this squiggle, on this error. It says that it must be set in the object initializer, or within an attribute constructor, right? Which is interesting, because in C# 1.0 we did have a way to kind of initialize, some data by setting a property at construction time, long before there were even object initializers, right? And that back in C# 1.0, and that was with attributes. So you could have an attribute. Let's say person. Actually, let's make this an attribute. So, suppose this were an attribute, right?
Yeah.
And then in here, you could say first name equals, the same thing, and we will get the same error that we did before. And so it's kind of this example of where when we do these features, we're not trying to, I guess, ignore the past, right? We want to take them and we want to, thread them all the way through the history of the language and find all the places where this would make sense. And so required properties are, in fact, they are enforced when you're in attributes as well, and another place where you get to decide a property at construction time.
Yeah, and indeed, attributes are these are going to come in quite handy in attributes if you ever make them. So
absolutely, yeah. And so required properties. Cool.
And no one's jumping in with questions at this point. So
I don't see any.
No, we don't have any questions
right.
just yet. We're just saying here in the studio how cool this is.
Okay. Well, I like to hear that as well. We must have explained this super clearly.
And it's the sort of thing that also, these things take a lot of time for us to get design, and so we did take all the time. And some of the things that we're not showing that are that you wouldn't see in this kind of typical very small example that we did take into consideration. Things like making sure that it worked all through inheritance hierarchies and scenarios like that. So this is a fully baked feature for C# 11.
Yeah. And there's a little, we're not going to show it, but there's a little escape hatch as well. So if you have multiple constructors and you want one of them to not require these properties when you're calling that constructor, like say you have a copy constructor that already initializes everything, then you can, there's an escape hatch. You can say, don't do it for this one. Don't give the errors with this when people call this constructor. So they're like, they're details, but yeah, let's not get into the weeds until we have more features under our belt.
All right. What do you want to move ahead then?
Let's do it.
Take a look at the next one. All right. There we go. What do we have here, Mads?
So here we have a very advanced numeric algorithm. It's numeric because it does some math. It uses plus. There's also a 0 in there. So of course, it's a simple example, but it's a real thing. There are a lot of numeric algorithms, both kind of like in our core libraries for standard things like averaging and so on, and also advanced stuff that people build libraries for in the ecosystem that does really advanced math for various purposes. And that is kind of showing a real weakness of C# all the way through the ages, and that it shares with many programming languages, which is that we can't really abstract over math. We can't talk about things that can do plus, So this algorithm is written in terms of int arrays. But if we wanted to also do float arrays and double arrays and matrix arrays or whatever, we have to write it again and again and again and again with exactly the same source code.
I'm very familiar. Yeah, it's called copy and paste, right? And then I change these to floats or doubles. Yeah, I'm very familiar with that.
And if you go and look at system.math, you have like dozens of overloads of some of these methods so that they apply to all our primitive numeric types.
In fact, it has, yeah, exactly.
Yeah, so we're like, enough of this. Let's find a way, So the ideal we would like is to be able to make a generic numeric algorithms to make add all, take a type parameter, let's call it T, and do everything in terms of T. Like we'll return a T, we'll take an array of T's, and so on in the body as well. So replace all the ints with T's.
T.
Yeah.
Yeah.
I think that got all the ints. And of course it doesn't work. But the way. What's that?
I said, so that'll just work, and you said no.
Yeah, almost. Well, Well, you can't just do things to type parameters, right? Usually, if you want to do specific things, you need a constraint. So, but what if we had a constraint that was like number or INumber? Here's an interface representing that something is a number. And ideally, that should work. That's how we do if we're trying to access instance members on T. You should probably put T there, INumber of T.
Oh, INumber of T. Yes, thank you. Sorry.
So essentially, this almost worked.
This up. Yeah, this works now, which is amazing. And I can see that now that when I hover over that plus equals, I see that it comes from another interface, addition operators, right?
Yes, that's brought in by INumber. And indeed, the T there, it's INumber of T because it takes the sort of the final type that implements the interface so that the operator can be in terms of the specific type. In this case, we're calling it with int, so that will be int, but the specific, it will be in terms of T rather than in terms of INumber itself. So
now, and this bit here, I know from the language that this literal 0 will be system.int32, right? It'll be determined to be an int, but there is no conversion from 0 to a T, right? There's nothing here that says int, so this doesn't work. But because we have constrained T to be INumber, anything that's static on T, and there's a lot of things on INumber, anything static on INumber, we can access. And so I can use this.
There's a 0 there. Yeah. So now, apparently this works. I mean, we could run it and see it work, but we just generified our algorithm, and to kind of prove it out, we can try to change what's in the array and see it's still working.
Yeah. So here it says it ran. It was 50. Yeah. No, I hadn't built since I installed this instance of Visual Studio, so cold start. So 15 it adds up to, but if I want to change one of these to say a double value, right? Then actually, what's kind of that doesn't change it to a double. But interestingly, I just want to point out that if I hover here, it is taking ints because this is an int array. But if I make this a double, now it takes, those are all treated as doubles. And so if I run that, which goes much faster because it's the second time, we get a totally different result because now we're adding up doubles and not ints.
Right. So, so something fantastic is going on here because this, you can immediately sort of see the benefits here because INumber is an interface. Like we'll have to go and see how this works. How does it do that? And we'll do that in a second. But you can see now that anybody can implement INumber or some of the interfaces that comprise INumber. INumber is a big one, but and participate in the generic math. So this algorithm will not just work for the built-in numeric types. It'll work for any numeric type that you built that satisfies the interfaces involved. And so essentially by providing some math interfaces and some magic to make them work, which we'll get into, we're opening up the not only for generic numeric math, but for everyone to participate in that ecosystem through these shared interfaces that we put in the core libraries.
Yeah. So I'm going to go ahead and just go to definition, navigate to this definition for INumber, and you had mentioned that it implements a lot of them. It's made up of a lot of interfaces. I would say that's pretty true.
That's a lot.
There are a lot because there are a lot of things you can do with numbers, but there's also some other things that have been added here. So here's this addition operators, right? And if we were to go to that one, here we can see there's the plus operator. In fact, there's two versions of it that are now the way this is defined and the way INumber is defined for the members it adds. These are static methods, static abstract methods, or in the case of this version, it's actually a default interface member as well, so it has a body there, which is why it's not defined as abstract, but it can still be implemented. So this is this is a really new feature that we've been, I don't know, it's been requested for years and years and years.
The first prototype was built, I think, 12 years ago now. But we finally felt that we could do this. It's a very deep thing in the runtime to build this, and we finally felt that we could do that. So yeah, the feature really, from a C# point of view, generic math is not the feature; it's the scenario. The language feature in C# that is the workhorse for this is static virtual members in interfaces. Is what we call it. Yeah. So virtual or abstract members that include operators, but can also be like we saw T.0. That was a static property, for instance, right? So static members can now be abstracted over in interfaces. And then
and this is kind of the big deal. I think we were talking about this yesterday, Matt, that this is the first time we've introduced a new way of, kind of performing abstraction in C# and in .NET really since generics.
Pretty much, yeah.
It's kind of a big deal, and we make a lot out of, like you were saying, we make a lot out of the generic math because it's a wonderful application of this functionality. But when we get down to it, it's really just a general feature that can be used to, to think differently or to use different ways of abstracting, kind of your architecture, your hierarchies, in your application to express yourself.
That's true. Often when we build, especially a big language feature like this, it's so important that we have a real scenario, strong scenario that we use to drive the design, even as we're thinking about other scenarios, that is delivered at the same time. Because otherwise we don't keep ourselves honest and we screw it up. And so in this case, we really wanted to deliver fully on generic math, even as we introduce this much more general feature. And you can see little language features that are specifically about the math also show up. Like the second operator there, you can see the checked keyword, and you're like, wait, I do operator overloading. I never knew that I could make it a checked overload of operator plus, and that's because you couldn't. That's a new thing as well. You can now have, if you want, you can introduce a separate overload for checked plus, and then that's the one that'll be called if you're in a checked context. So if you want to introduce that distinction, you can. That used to be reserved for just built-in types, and now you can plug into that with your own operators as well. So that's like, we added these little extra nibbles around the edge to make sure that the math scenario is fully there. But the key feature here from a language point of view is much more general.
Yeah. And you can see that if we go back to some of the other, sorry, I've been moving around a lot here. Let me see if I can get back. Oh, here, I'll just go back to INumber. And we can see that there are other interfaces on here that actually have nothing to do with math, right? And some of them are new, that also have generic interfaces. Sorry, static abstract interfaces on them, members on those interfaces. So like this one is an old one. This is one's from .NET 1.0, and it's iformatable. It's the thing that gets used by toString and format providers, and there's a whole kind of infrastructure for that in .NET. And the idea is to take an object, an instance of an object, and be able to then convert that, format that as something else, typically as a string. That's cool, but we've never been able to really do the reverse of that, right? Which you see on some of our number types. You see, well, most of our number types, or all of them, maybe. You see like parse methods and try parse methods on int32. And there was no abstraction for that. Now there is, because those methods have to be static, right? Because they're going to take a string and return another thing, but you don't have an instance to call them from. So we call this iParsable. And here we have, in fact, so then we have static abstract methods for parse and try parse. And what's cool about this is that it's kind of, Mads, you had a great way of describing this as a factory pattern, right?
Yeah, if you look at the parse method there, it is like the iParsable interface is going to be implemented by lots of types that you want, but those are the types that we want to have as results of the parse method, but we don't have them when you call it. So it has to be static. So it is really like a static. So if you think about the individual parse methods on int.32 or int32, for instance, the parse method there is really a factory for ints. So it's a static factory. But now that we can abstract over them, it's also an abstract factory, right? So there are these design patterns, static factory and abstract factory, and you kind of, in the past, you've had to decide whether to use one or the other. When you use an abstract factory, you need to like have a separate hierarchy of factories to produce instances of a hierarchy over here. But now we can have static abstract factories. This parse is a static abstract factory method. It's abstracted up to a base type, but it's static. It's called on the type, not on the instance. So this is a very powerful. It's like expressiveness that is kind of like fundamentally new if you think about it. Very few languages can sort of just let you do that, and it opens up these new possibilities, as Dustin said, for ways that you can abstract.
I think this is I mean, what I like about this particular example is that, I mean, this is your serialization interfaces, right? To serialize or deserialize, and now being able to have interfaces that can abstract over the entire concept. You could always have serialization, right? Because you have an instance of an object that you're going to turn into some other form. But now you can have the static version that deserializes, given something, some t, be able to, and given some other form, be able to turn it into an instance of your t, right? This is pretty powerful stuff, and this is already in the BCL, in the base class library. We use it in not just numbers, right? But there are other structures that aren't really numbers exactly. GUID, for example, has parse and try parse methods and always has. Well, now it also implements iParsable of GUID, right? So it can be treated in the same way. So I could write a method that abstracts over iParsable of t and be able to pass anything that implements that, and be able to take a string and turn, if it supports that string, then be able to turn it into an instance of that particular type. Very cool stuff.
That's exactly right. And you can see this one is just in the system namespace. This is not specific to system.numeric. iParsable is
that's right.
Just a general thing. And I think we're just scratching the surface here. Like, we haven't even gone through systematically and looked at all the original design patterns or other things out there to see, like, can some of them be improved in the same way as the factories? We did, I think, in a certain an implementation detail somewhere in the BCL, we used this for like strategies as well, and we can imagine now a class with static members can be a strategy instead of having to have an instance object that represents a strategy, and you can just sort of keep going. And honestly, we're like super curious to see what the community comes up with in terms of using this new abstraction mechanism. There's going to be like so much we haven't thought of that's going to be possible with this. So tell us if you've come up with something cool with this. Yeah, shoot us an email. That'll be really fun to see.
There is Carl, actually. Carl is asking a question on YouTube there, but with in the chat, about asking if there's a demo app that's been released, kind of with, that shows how to use all these new things. I don't know that we have kind of a giant app of kind of the like the motivating kind of examples of why would use those, or any kind of real sample app. There's some snippets in blogs and things like that, but really the power is in all of the interfaces, which are included in .NET 7. They're just they're there and ready to be used as is. But there isn't. I don't know that we have a great demo app. Do you know of anything, Mads?
I don't. We should probably track down a little more of what's being done in the community. And I think the BCL team, the core libraries team, has been a little more in contact with some of the existing math frameworks out there. So yeah, I'm not aware. There might be something. It'll more likely that it's built elsewhere in the ecosystem. I mean, I want to point out a concrete example of why do you want to abstract. think about a matrix type, for instance. If you want a matrix in the sort of mathematical sense, has operators, matrices have operators on them to like multiply and add and so on. Now instead of having matrix of int, matrix of double and so on, you could have a generic matrix type where the element type is the type parameter, and it's constrained by the elements having the operators needed in order to implement the matrix level operations. It's that kind of abstractability that becomes really powerful.
Yes.
Cool.
So this is awesome. So let's take a deeper look at this now. There are no other questions that I see in the chat. Is there anything else?
Anything from the studio?
I don't have so much of a question. I was just going to say actually the I parsable, for example, is really valuable and could be used in Umbraco because we have some custom types. We call them UDIs. They're kind of a reference, if you will, to different parts of the system. And then we have GUID-based UDIs and we have string-based UDIs. And so we have different classes for parsing those. And then, well, how you parse or try and pass between them is a mess. So actually being able to implement on the base UDI type to say these are all iParsable is great. It's a generic, I guess, we were missing before that maybe felt overkill to put directly into the core product, but it's in the language now, so we could.
Yeah,
that's an awesome example.
That's fantastic.
Yeah. If you go through with that, I'd love to kind of like see the outcome of that. So yeah. Awesome. Cool. Dustin, now should we move on to the next one?
I think so, but we're going to stick with this code, right? I think we took a look at this and we decided that this is not, I don't know, the coolest way to write this method.
It might be the best, but it's not the coolest. It's not the grooviest.
It's not the grooviest, indeed.
Yes.
Yeah. And so we'd like to re-implement this using something that we have been working on since C#7 and continue to iterate on over multiple releases, right? In C#7, we introduced pattern matching, and pattern matching is kind of a really great example of how we think about C# language design now than we did in the C#3 days. In the C#3 days, or in the C#5 or 4, we would sit and think for a long time and design and build and prototype and finally come out in 2 to 3 years with a new language, and that would have link in its totality, or it'd have async in its totality. And as we've accelerated the release of the language, we have instead introduced features and then continue to refine those or add functionality to them over release, right? And pattern matching is a great example of that. So we're gonna do this in a pattern match style. So I'm going to turn this into an expression-bodied member here. Did I do that wrong? I didn't do that wrong, did I?
Well, you just didn't do this. You didn't write the switch yet.
Oh, yeah, sorry, I have to write the switch. So yeah, so I want to say values, and we're going to switch on that, and given our body here. And so we're going to rewrite this using pattern matching and a switch expression, which was introduced, I think, in C#8, 9?
8, I want to say.
It's hard to keep track now. It's getting harder to keep track. And right now we have a warning on here because this is the value of a switch expression where it does the analysis to let us know whether we've handled all the possible inputs that are going to come into this, all the possible values of, or inputs that could be an array of T. And as it says, for example, the underscore or the discard pattern is not covered, right? So we could just cover this by putting the discard pattern, but that would not be very useful.
Right.
So instead, we should start handling some of the cases.
And this is where the new the new pattern of this version of C# comes in. So we've added list patterns to C#, which are for examining and deconstructing collection-like structures, list-like structures. So, and this is a concept that's very familiar from functional languages, where pattern matching in general comes from, but functional languages may not be familiar to many of you. But list patterns are typically one of the workhorses there, and we found what we think is the right way of doing them in C#. So I guess we should, we should start small.
The first one to handle, though, is the empty case, right? Where we know there's nothing in there. So it's going to return, not 0, sorry, T.
We're abstracted now.
Yes, we're in full abstraction mode. But of course, we don't handle everything, right? And this time it gives us a helpful hint on the switch. It says, for example, the pattern of length 1 is not covered, right? So we could go ahead and cover that as well. So again, I'll use a list pattern, but this time I'll use another pattern just to indicate this is a list of one item. And in this case, we just return that. Turn that first that item because that is all of them added up. Of course, now it says length of 2 is not covered. Well, so we could continue doing this for.
We could do this for quite a while,
for quite a while, and that would, and of course we haven't covered length of 3. So, but there's got to be a better way at this point, right?
Yeah, we need to somehow be able to grab some elements and then whatever is left, like have a variable, match a variable size list, and get a hold of whatever we didn't specifically match out in, whichever elements we didn't explicitly match out.
And to do that is with ... We introduced range expressions and that also contained ... as as sort of a way to define, fill in the space here, right? And so that's what we're asking it to do. We're asking it to take the first item and then fill in this, and then take the rest of it. In fact, we'll just call this rest at this point. Okay, and if I hover over that, I see that it's actually a T array, and it will be a T array that contains everything after the first element. And the first element will be in its own variable, and then the rest will contain that. So we can't just add them together, right? But we can call this recursively,
of course,
like so. And now we have no warning because we've handled everything. There's always a case where there's and everything else, even if it's a list of one element, actually, right? So if we were to move this up, we would see that actually this will handle the case below, and that this is actually unreachable now, right? Another value of using switch expressions. So we can generalize it to just that.
That is elegant.
Yeah, I love it.
This is
I assume it performs really well.
Well, now might be a good time to talk about how this is all implemented. The way that the compiler determines, what can be list pattern matched against and how to extract the data actually goes back to another C#8 feature, which is, you mentioned a little bit, index and range, where, we need to be able to. So essentially, we need to be able to ask the collection, the incoming value, how big are you? We need to be able to index and get specific elements at specific positions, including from the end. And the last thing, if we want to use the ... we need to be able to slice, which is also slicing is also a feature of C#8. Actually using ranges to indexing with ranges slices. So we just fall back on those same concepts, those same patterns of code, if you will, or surface area of the incoming object.
But Mads, when I slice on an array, that gives me a brand new array, right?
Yeah.
it's this
Yeah.
it's a new object, so it has to copy everything that's remaining into this new array. So we replaced for each, which was, you know, a really efficient way to do that. It used special IL instructions for accessing the array and all that. It was very, very efficient. And we have now turned this into kind of kind of an allocation, you know, hungry algorithm.
It's quadratic, yeah, in both
Yeah, it was not quadratic
space
before,
and
yeah.
time. I mean, back then we decided that slicing, the way slicing should work is just so that it would be more understandable. It should, and this is not like a language thing, this is a BCL convention. Everything that
Yes.
offers up a slicing method returns the same type as you call it on. So that's easy to reason about. So if you slice an array, you get a smaller array. If you slice a string, you get a smaller string. All of which involves copying and allocating. If you slice a span, then a span is just a start pointer and a length to some memory. Then that's really cheap because you just get a smaller span on pointing to the same memory. So that involves no like copying or allocation. So once you're doing slicing, whether you're doing it directly or you're doing it with the list patterns here, it's really important to think about what's the efficiency of your slicing and how often are you going to do it. Like, are you doing it recursively like we did here? So yes, if we turn this all into
now that values is a span of t, so it's still an array, right? Inside there is still this array of 5 doubles that we defined above on line 1, but now we're treating it as a span. Span being a very, very efficient struct that can only be allocated on the stack and all of that. Now when we call that in here, rest produces a new span, but that span is still it's slicing on the same array underneath, right? So that we're not creating new arrays, we're not copying things. We're just creating kind of a new window into that array and calling it recursively.
Yeah, that array that you're creating on line 1 is the array that we're looking at all the time now. Like every recursive call is looking at the same array. It's just looking at it through a narrower and narrower lens until it gets to the bottom of it.
Right. And so this winds up being fairly efficient, uses the call stack, but you could probably refactor it not to. So that's cool.
So
I don't see any questions about this out in the kind of the in the interwebs.
Okay. Interwebs, that's a fancy new word. We didn't use that when I joined Microsoft.
No, we didn't. When you joined Microsoft, there was no internet, right?
That's true. Yeah, we had to invent it first. So anything from the studio?
No, I don't think so. This is really interesting. Looking at the performance side of things isn't really something I'd considered with any of these new operators. Now, pattern matching, we were having a bit of a debate about whether we like it or not because, well, for me, I find the syntax a little bit headachy, shall we say? Like, I totally understand it with the range operator there. Everything you're showing makes sense, and it's definitely allowing me to write much more powerful code without having far fewer lines. But then it requires a little bit more thought maybe than the alternative. But I'm kind of interested in the idea here where you could inadvertently introduce completely unnecessary amount of allocations or something like you were just discussing there with the pattern matching of a thing with a range operator and everything. It's interesting. I guess it's a preference at this point. People have choice, don't they?
In a sense, yeah, I think they do have choice. I think one of the things that's kind of interesting is that this becomes, like in the past, some people might have said the same thing about, say, like lambda expressions, which have become very common and very comfortable. But back in the C#3 days, it was harder to read, but it's become a little bit more natural. So maybe that's where this goes.
To be fair, maybe I'm the weird one here because even the null coalescing operator, like that took a while for me to get used to as an idea, and it's finally ingrained now. But I'm still coming around to pattern matching.
In
Yeah,
fact,
and I
we were
think
just
it's
discussing about pattern matching, isn't it? How we can write an entire blog post just about pattern matching, because that's something we are seeing more of with every C# version that's being released.
yeah, we are leaning hard into pattern matching because we think it cleans up code extremely nicely, and for more and more scenarios, right? The original scenario for pattern matching that we added it for, fully expecting to expand, but the key scenario back then was these situations where you wanted to type switch. That was the core scenario. Is it this? Is it that? Is it those? That was very awkward code in C#. You had to first do the type test, and then you had to cast again to the same type or other patterns using as and checking for null and that kind of stuff. It was ugly, and then we started introducing recursive or nested patterns of many kinds. The list pattern is an example of that, where there are other patterns inside, the var patterns inside there. And of course, that can easily be overused so that you get very, very long, complex patterns. But generally, if you use it just a little bit, it can help get rid of a lot of if then else imperative code that makes it extremely hard to reason about, well, when am I in this branch? And is there a branch? And is there like data that can have me fall through and I don't go into any branch, or what is the state of things when I get there? With a switch expression, we find that once you get into the habit of designing them well and writing them well, you get some extremely readable code in the sense that you can see it's this, 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 or this in that order. And it also gives us the freedom as compiler implementers to implement this as efficiently as we can. We do a lot of common sub-expression stuff. We eliminate evaluation up until the point where you need it, and then we reuse the result of it, and so on. So we can very efficiently, using like the latest in decision trees and so on, implement this. So pattern matching and switch expressions are in fact very efficient.
Yep.
The fact that in this case the list pattern relies on slicing, and slicing on specific types is not necessarily efficient. That's not really that's a little like language lawyery, but that's not really a feature of the language. It's a result of a choice we made on how slicing should work on the platform. But pattern matching itself can often be more efficient than the equivalent if then else code, as well as much nicer to read. So
yeah, I
that was
think
a little sell job in that.
Yeah, that was a nice sell job. I think when I get down to it, and I tend to agree with both of you in a way, but what it comes down to is just because we put it in the language doesn't mean you can't use it tastefully, right? And there comes a point where readability and performance and all those things have to be balanced, right? And so making something sensible and readable is kind of first and foremost. If I had this, this particular switch, case with pattern matching in it, I much prefer that now to, if O is string, then do this. If O is int, then do this. I much prefer this as a way of expressing myself, and I find it more readable. But it could be taken pretty far.
Yeah, I can see definitely in a more extreme case that would be far messier.
Yeah.
And actually the pattern matching equivalent would be far cleaner. I think it's in the more complex cases, you say lists and in switches and stuff, that it's where I've been more resistant to it. Maybe because when we're doing a switch, it's generally more complex stuff. But no, I think both of your arguments are very valid there.
Well, Mats, before we run out of time, though, we should run over to our last demo.
We have one
more thing to talk about. Yeah. Yes. The sleeper hit of C#11. This was something we weren't sure was going to be magnificent, and it turned out to be wow. It really has changed the way I write strings literals in a lot of cases. So Go ahead, Mads. Give us the rundown.
Yeah. Okay. So, like, oftentimes you want to quote code into string literals in your C#, and code is broadly defined as things that have lots of symbols in them. In this case, XML, for instance, and XML has quotes in it. So after you copy paste your XML from somewhere, now you have to go and escape those quotes in order to fit them into a C# string, because the quotes end. So they're escaped in here, and if we didn't, it would be a mess. And we decided now's the time to have the string literal to end all string literals. You can record this and come back and haunt me in a couple of years when we introduce a new kind. But the string literal to end all string literals that cannot have escapes in it of any kind. So you can copy paste anything into it. And that's denoted by 3 double quotes instead of 1.
More quotes. MOAR quotes.
Yes, more quotes.
Yeah.
And so now if you run it with those, you can, do it.
Yep, I did. And now you can see the slashes are in there because we didn't need to escape those in the first place. We can just
They're part of the content now. Yep.
Yeah.
Slashes are content. Quotes are content. Everything is content. Yeah. And now, of course, somebody will say, well, what if I wanted to quote this?
What if I want this?
Yeah, I wanted to quote this program. I want to quote something with 3 quotes in it. Ah, you got us. Okay.
Well, what's the answer? It's MOAR, more quotes, right?
More quotes.
So make it 4.
We'll just beat you back with more. And so regardless of how many quotes are in the thing that you want to quote, just quote it more, and it'll still be content.
Just need one more, just that one more quote.
Just take it to 11.
Can I jump in with a question quickly here? I mean, this is the HTML example here is perfect because I mean I've done some dirty things in Razor to make this actually render exactly what I need, maybe for a JavaScript library or inline things. It's never nice. But I just wanted to check, this will also work in Razor?
Yeah.
Not yet.
Not yet.
Sadly, we're working on it. Actually, I'm working on Razor right now, and we're actually working on getting these raw string literals working within Razor pages right now.
Fantastic. So at some point in future, my Razor code can be nice and clean, and I don't have to worry about this.
That's going to be every Umbraco dev's dream come true.
That is going to be a bumper feature. Yeah, when you're building content managed dynamic websites with lots of, when you need to be able to interpolate markup, kind of as you've been showing here, having that feature would be so valuable. So valuable.
Well, that explains the applause I got last year.
Yeah.
On this one.
Yeah. But they do get better, right? Because like a verbatim string, they can be multi-line, right? And so I could have my content on multiple lines as well.
Oh, you totally had me there.
Right. And now if I run that, what's interesting about this is you see how it's left flushed, right? All the way flushed to the left. And that's because the way that we determine that is wherever this final delimiter is. You see how if you look closely, there's this faint gray line there. Well, if I were to take this and move it back, you can see it's drawing that faint gray line further to the left. And that's how we determine how much of the left kind of chunk, the white space on the left will get taken off of the final string literal. So this is extremely useful in general, because it means you don't have to contort your code that's defining string literals in a way that is just makes it look bad just to get those string literals to actually format correctly in the end.
Yeah, you can both have them placed you can have the literals at the right place in your code, as well as indented to the right place when used as, in the outcome of what string they produce.
Yeah. But they have to be 3 quotes, because quote means something. It means start a string literal, and 2 quotes means, empty string. So it has to be at least 3.
Yeah. And of course, you also want to interpolate these, right?
yeah, you want to be able to put a $sign at the front, just
Mhm.
like any old string literal from C#6, and be able to put an interpolation in here that will be computed in the string literal.
And if you wanted curlies in your content, well, of course you could just not interpolate. But what if I want both curlies in my content and I also want interpolation? Like how do we deal with that?
Yeah.
It's the answer is similar to what we did with the number of double quotes, is that the number of $signs determines how many open quotes and close quotes it takes to delimit an interpolation hole. Right?
What I love about this message, it says it does not start with enough $sign characters. It's still the answer is more. MOAR. And so now that's an interpolation, but if I were to not have to, if I had then single curly braces, those you can see that they're colorized as part of the string literal, and they will be part of the content. So if I run this, you'll get a 42 in braces in the middle.
Yes. So so if you want interpolation and you also want curlies in your content, then you take one more $sign than the highest number of consecutive curlies you want in your content, and then put your interpolation holes in with that many curlies. That's how it goes. And it sounds silly when you think about 5 or 6 or 7, but in general, you sort of typically only need to like push it over one or two, right? That's going to be the common case.
Yeah, and one of the things I really liked about this idea of a feature, because it was something that, it seemed silly at first, and it seemed kind of weird in a way, but really, if you think of it like, instead of the language dictating how your content must be formatted to make the language happy, instead, we've added rules to say, okay, let your content be your content, and you tell us how it should be organized, and we provided ways for you to tell us. And I think it's to tell the language what to do, and I think that's fantastic.
That's true. Yeah, it kind of flips the script on its head.
Yeah.
Then content is king.
So, well, I think we're at time, actually. So,
and this is all we have to show.
So, these are kind of the core features that are coming in C#11, or that are here. Sorry, that it shipped in November.
Welcome back, Mats and Dustin. I'm going to continue the trend saying I love string literals, raw string literals. Yep. It's fantastic.
I think we've all got big smiles on our faces here, just seeing like we just add more $signs, more quotes, and it makes a lot of sense. It's really powerful. I especially love, as you showed there, this sort of controlling the indentation. The fact that you've finally got control of that without having to do really, really questionable things in strings is awesome.
This, when it comes to Razor, is going to be incredibly powerful and absolutely valuable for devs who play with content, dynamic content like us. It's going to be fantastic. It's going to change our lives.
Yeah, and definitely in a few times a year I have to do something like that. I feel bad. So whenever we get something, we'll worship you, Dustin.
I feel bad because you have to keep doing it for the meantime, because we actually are actively working on updating the Razor compiler to be able to handle them. So,
awesome.
Unfortunately, it always kind of trails a little bit behind the C# language as it gets out there, and so we have to go do that soon, and it's one of our top requests. So I will count these as votes.
It's a really good question, actually. Could you just explain maybe how that's handled internally? So you're here designing C# language features. How does the support for those get into Razor eventually? What's the process?
Well, so nowadays, it used to be that the Razor compiler and the Razor tooling was fully owned by the ASP.NET Core team that also owns the runtime and a lot of that. But nowadays, it's actually owned by the same team. The Razor compiler is owned by the same team that owns C# and Visual Basic, that owns the Roslyn compilers. It's some of the same people working on that, and so compiler experts, really. And so they as we do these features in C#, one of the nice things moving forward is that as we're doing features in C#, there will be people thinking about, okay, now how do we get that in Razor, right? Because Razor is a wholly different implementation of parser, and so they're always kind of playing catch up with C# language features. So the hope is that we'll be able to get there much more quickly, and with I guess a little bit more thoughtfully in the future. So that's kind of how it used to go. It was a little bit slower. There was a little bit more lag time, and now kind of the same people are there. So hopefully it goes a little faster.
That's awesome. Pretty awesome.
Yeah, let's come back to the topic about the second demo that you showed us about generic math calculations. I found that incredibly powerful. I think it'll take time for me to wrap my head around it. I think I personally need to read up more, but it was very evident from the way you both presented it, how excited you both are about that feature.
Yeah, I can see use cases for us in like some of the things we've done with e-commerce, where sometimes we need maybe display pricing, and so it can be something, and sometimes we're needing to do proper full-blown calculations. And
Yeah.
so having the ability to have generic types there is actually super powerful, because something could be an integer for display, or it could be it might need to be a decimal when we're doing math on it. So that's awesome.
It brings into it kind of ushers in a new generation of currency types in a lot of ways, right? And where potentially we could see things could get cleaner. It could improve the kinds of bugs that we find in that sort of less business logic based around numbers that aren't just about mathematics, traditional academic mathematics, or research, but also just around, the business of doing e-commerce. It makes lots of
implementations of mathematics, right? Yeah, it's always so painful every time I have to do maths myself. Like for an e-commerce store, I don't want to. We want to avoid it at all costs. So if the language can make any of that as nice as possible for us, that would be awesome.
We try. And also just I have to admit that part of my excitement is, as a language designer, it's just a really fun, it's a perfect kind of feature to get to work on, because it's like, it's big and mind-boggling and kind of breaks new ground. So it's exciting to work on that. It has very useful concrete scenarios right away. And it had lots of collaboration between many different teams inside of Microsoft and outside, and it ended up really well. So it like the design we ended up with feels like super solid, and I'm very proud of what we did there. So that's just like one of those rides that you once in a while you just get a real hit of a language feature from that perspective as well. And that's yeah, I enjoyed every bit of it.
That's good.
While we are on the topic of Umbraco Community Day still, Matt, Dustin, is there something that stands out to you in C# 11 as a feature which had a huge like a community ask for it, or a community upvote for something?
Well, several of these were quite popular in different ways. There were, let me see. There were things that didn't quite make it that had a lot of community interest as well, that we fully intended to get into C# 11, and we ran into problems around making it elegant and backwards compatible at the same time. So that's a discussion that we're now having of how to best handle that. So, but I think several of these were quite popular. I don't know that I think raw string literals was in fact like one of the most upvoted of the ones we did.
Like I say, it was a sleeper hit. That was the one we didn't expect to have such fanfare. And as soon as we started using it, we're like, oh, well, why was I skeptical?
I know
it's one thing to be skeptical in the design meeting.
I know Matt's presented about this at Code Garden last year, and I was like, Whoopee, I love that.
Yeah. Mads, you
It's a
mentioned
nice one to end on. When you have to face people in the hallways after, it's good to end with a thing like that.
It's definitely a crowd pleaser, yeah. Mads, you mentioned a couple of features that were left on the cutting room floor, and I'm going to ask maybe a divisive question here, but I can't remember the official name of this. What is it? I'm going to call it the bang bang operator, the double exclamation point operator. So
yes,
it didn't make it into C#.
It didn't make it.
So for those that don't know, it's basically a parameter null checking or something. I don't know what the official name was.
Null argument checking.
Null argument checking.
Yeah, null argument checking. So the idea was that instead of writing a line of code to check that a given argument is not null, we could sort of generate that for you with a little bit of syntax on the parameter itself. And it was a feature that remained controversial. There was always like essentially in every forum we asked, including ourselves as a design team, internally, externally, MVPs, the full community, the people who hang out on GitHub, we got like 60% were in favor of the feature, 40% were against it, 60% were in favor of the syntax we chose, 40% were against it. It was always like, okay, so if this was a democracy, it would be voted in, but also C# has a kind of like a limited budget of surface area. We have to be careful to only add the most exciting, useful long-term things. And if you have something that is so controversial, maybe that's not where we should be spending that budget. Even if, I mean, I felt like it was a nice feature. I was, if I was a dictator, I would have put it in. but I wanted to, and we wanted to land it where we said, okay, maybe someday there'll be a better syntax for this, or there'll be a better way of doing it, or people will feel differently about it for some reason, but not right now.
Yeah. So is this a never say never, or it's probably never going to happen type thing?
It's both.
Okay.
It's probably
60% of one and 40% of the other.
Happen. It's probably never going to happen, but never say never.
Yeah, I saw James Newton King the other day tweeted something. I think there's a new, I can't remember what it is, but there's a new method or something somewhere that we can use to do effectively the exact same thing and just make that a lot cleaner. So that's positive.
It's actually on argument null exception. You can call argument null exception dot throw if null.
That's
I think
one.
is what it is.
I was actually thinking about it.
And you just pass in the argument and it just works.
Yeah.
I
mean,
and
for
it
me,
prints
that
the right message.
That feels far more friendly and achieves the same result. And okay, you have to write a couple of extra characters to get it there, but it's clearer. It's far more verbose to someone that's maybe coming from another language as well.
Yeah. And I would love to add to what Mads said about the community being divided, but also the language design team was also divided. I did not like it. Personally, I had other ideas about what the syntax should be, and when it came down to it, people felt strangely passionate about it, right? Like to the degree they'd say, well, you know what? If I can't get it this way, I don't think we should do it at all. And it got so the controversy wasn't just the community; it was also it didn't settle right within our team. And when language features settle, we know it. We're like, this feels right, and most people in the language team have come to the conclusion that yes, this makes sense. But in this case, it was just as divided.
You don't want controversial things really in the language, because if, as Mads, you said, 60-40, if 40% of your users, or at least the ones that were polled, but if 40% of your people who are actively using this language on a day-to-day basis despise an element of it, then it's not going to be a nice thing to work with. So it's not an element of democracy. It's like it needs to be an overwhelming majority, really, for one of these decisions to be made. I feel. I don't know how you think about that.
No, I think that is generally true. It kind of depends where the resistance comes from, because we also have to be bold and go forward. So sometimes it's pattern matching, where it takes a while before people are comfortable with it, but we sort of say we believe in this. We take the leap of faith for you, and you can grow into it because we believe eventually you'll be happy. So it's more that we did more of the thinking more ahead of time, and and it takes a while for people to fully sort of inhabit the new thought patterns that come along with it. So I think that for that kind of features, it can be a little dangerous to ask people like, how many people like it? There'll be a lot of like, I'm not sure. I don't think I like it because it feels strange to me right now. So sometimes we just have to trust ourselves to go forward with those things. But that requires that we as a design team jointly feel that is the cause of the resistance. And in this case, it wasn't the cause of the resistance. It's not that people couldn't wrap their minds around what it did. Nobody had a problem wrapping their minds around generating one line of code. It was a different kind of resistance. It was like, this is icky, I don't like it. Yeah. And when that's the kind of reaction, then okay, that's a different game.
Yeah, I guess my biggest takeaway from this whole talk has been that you're giving people choice. With everything you do, you're giving people as much choice as possible. So people can use these new features. They don't have to. You don't want to use implement the new interfaces on any type you create for, if you're doing math stuff, that's absolutely fine. You don't have to. But if you do, then you'll also get some benefits from it. So there's options. People have choice.
That's true to some degree. Again, I'm going to counter you a little bit because it's not just about giving people choice, because you also have to be careful about not offering every language feature on the planet or every different way of doing the same thing. We add features when we feel that by and large, or in a large number of scenarios, they are a better way of doing the thing than what you could do up until now. Like we don't want to just have different, we want to have better. And we're not going to do just different. And this is in fact like one of the features that has the most upvotes and the most people clamoring in C# is discriminated unions, which is essentially a different way of describing your data shapes, right? An alternative to inheritance, if you will. That is very popular in functional programming languages. And we are interested in that interest. We want to find out, and what is it about discriminated unions that make you happy? Can we extract sort of the essence of that and add it with minimal overhead to what's already in C# and make the existing ways better somehow, but just adding like an alternative next to what's already there and say, if this is your taste, do that. If this is your taste, do that. That is something that we're very wary of, because now we're just bloating the language. We want to give you the benefits that you're asking for without giving you choice just for the sake of choice.
That's a very good answer. Very, very good answer. Both of you, this has been lovely, really lovely. Thank you so much. I think we could sit here for hours and probably and geek out and ask you loads of questions. But yeah, this has truly been a pleasure. Hopefully, we get to see you at some other Umbraco events or .NET events, etc. In person, maybe soon as well. Would be awesome. Thank you so much, both. And yeah,
thank you so much.
We'll see you around. We're going to go to a very quick interlude, and then we'll be back in a second.